Welcome back, Tulare fans. Today we're going to discuss basic QoS. On each Tulare appliance, they ship with a set of defaults that comes on the box by default, and that's going to, depending upon your traffic type, that's going to treat the traffic differently. Now, just because they're defaults doesn't mean they work for 100% of the networks. Typically, they only work for about 90% of the networks. So what do you do when you run into some situations where you need to add some rules or classes or tweak some applications? Well, you got to change some things. So we have a couple ways to do that. As I said, we've got the defaults on the box, which I'll show you a little bit later, and we can change a rule locally or we can change it globally. The first thing I'm going to show you is how to change it globally to where it's enacted on all the conduits within your network. Alright? And that's by creating a conduit default set. We go to default sets, conduit default sets, and then we'll create a class and then the rules and then enact it. In fact, first let's just do this. Let's just rename it, and we're going to rename this QoS, and then we're going to start configuring. Okay. Alright, so first things first, we got that. And then let's go to classes and talk about that. So here are your classes. 10 through 16 are the defaults that come on the box, starting with real-time, interactive, and bulk. And then 0 through 9 are our user configurable classes. And let's talk about what each class does. Now, before I get there, if you're familiar with the Cisco IOS way of doing QoS, then you're familiar with ACLs and policy maps. Now, rules here is like our ACL. That is matches on the traffic type and lets us know what to do with the traffic once we've matched on the traffic type. And then it'll go to classes, which are like the policy maps. Is all right. Well, how do we treat that traffic a little bit granularly? Okay. So this is our policy map. This is our ACL. So here, if we were going to create a class, we could go in here and we could say, all right, class 5, let's call it important traffic, right? Maybe not real-time important, maybe not the critical, right? So we get these three options with the type. We get real-time, which is, that's going to be your voice. That's going to be, it's better to drop the packet than to delay it. This is critical, cream de la creme. And then your interactive, that's going to be your keystrokes. Hit keystrokes on one side, something else happens on the other. Maybe it's Citrix, maybe it's RDP, maybe it's video. I move around in video, and then on the other side it's video. But that's going to be my interactive. Initial and sustained rate. Initial says, well, that's how long of a period and what rate before switching to the sustained rate of this is how long it's going to be for the rest of the time. All right. Here we're just going to put in 15%, and we'll just keep it easy and stick with the sustained. All right. All right. So we've added a class, important, interactive, with a 15% share. Now let's add a rule that says, all right, this is what traffic to match on for this important one. All right. So we add a rule, and this is the ordering system similar to an ACL. You can move it up and down with numbers. And application name. If we had added a name on a separate set of the configuration, we could hit the drop down here and hit the name. So let's just say this is an actual IP address here. Let's do source and destination 10.10.10.100/32, and it can be source or destination, and that protocol is going to be some TCP, and the port, I'm going to say any, although I could put in a port range if I wanted to, using a dash or anything like that. And then I could rebind the flow if it changed, if I was matching on a DSCP tag and that tag changed. And in this situation, I don't care. Now I'm going to hit the plus sign here to give me some options. This is what I'm matching on, but This is the difference with Telari and QoS. You know, this is where the magic happens, and this is a differentiator. So just because we're matching on traffic doesn't mean we can do some special things. Being a two-ended solution gives us the ability to put some magic swirls on that traffic and make stuff happen that other people can't. So let's look at the transmit mode. So we've got load balance paths. So load balance paths, that's our bread and butter. You know, that's where we're going to pick the lowest latency path, and we're going to break up the flow packet by packet and send those packets down the lowest latency path, and then reassemble at the far side. Persistent path. Persistent path is almost like a VPN tunnel. We'll use one WAN link, and we'll send all the packets down that one WAN link. If that one WAN link goes bad, we'll shift it to the other WAN link. Now, if that WAN link that went bad, even though it's the best, comes back, we'll stick on that same WAN link that we're on now. It's almost like a sticky WAN link. So unless the path goes bad, we're sticky on there. All right. Duplicate paths. Well, that means I'm going to take a copy of every packet, send it down both links simultaneously. First packet that arrives the other side wins, and then I squelch the last arriving one. So duplicate paths is perfect for voice and any other type of critical traffic, but if you have a high volume of traffic, it's going to cost you twice the bandwidth. So there's some costs associated with that. And override service. Override service would be if I wanted it, it was taking the conduit service, I could then send it to discard internet or pass through. Alright, but that's not what we need there either. We're going to do load balance paths, and we're going to retransmit lost packets, which basically means we're going to mitigate that loss, right? So I'm sending sequence number 1, 2, 3, 4, 5 to the far side. 1, 2, 3, 5 gets there. Well, then to Solari's talk and say, hey, here's the 4, I'm sending it. So we have that. Now there are some traffic optimization options. We have TCP termination for those high latency links. That'll get the traffic moving fast. That's where the Telari gets in the middle of that handshake, and we buffer up the traffic, and we can get that traffic screaming. Now, if you currently have some optimization in place, there may be some interoperability there, issues there. But header compression. We can do some stuff with the headers and save you some traffic on the front side. Enable packet aggregation. We're taking a whole bunch of little packets and putting them into one big packet and sending it. And then we can also track that performance. So if we name this application, or we can track this performance and see how this application is actually performing through our statistics. And in Aware, we can do some MOS scoring as well. So we have that. Now, we need on WAN ingress into the WAN, we need to define a class for our important traffic. What are we going to define it as? Well, I'm going to put that as class 5 and make sure it's in the class that I created for it. As far as the defaults for the drop limit and the drop depth, I am going to keep this as the default for now, and I can always increase my drop depth if I want to, but you got to be careful, right? With interactive, I'm using time and queue depth to know my drops, so I don't want to delay that packet too much, right? So I'll just keep it as my defaults and see where it goes. We can also reassign flows based upon packet sizes, and then disable duplicate packets based upon queue depth. So if we went down to one link, we wouldn't send 2 packets out the same link. You'd get back up on that packet. And then also we have the TCP standalone ACK class, where we can assign that class as a lower priority class, so the ACKs get sent faster than the actual traffic. All right. So let's go to WAN egress. So here, by default, we're going to enable packet resequencing. We're going to resequence the packing on the far side, and we're going to discard the late resequence packets. Now the whole time for WAN egress, and this is going to be how long do we wait? If we've sent a packet, how long do we wait for that other packet, that's lost to arrive? Well, it's going to depend, and there's some good rule of thumbs, right? So 80 milliseconds is default hold time. That's typically good for voice. 250 milliseconds is usually really good for TCP, for Citrix, things like that. If you're doing video, you may want to get a little lower. But in this situation, we're going to be 250 milliseconds, and it would be any DCP tag. And then we also have an option if you have passive FTP. Alright, so let's go ahead and hit apply here. And we have a warning. As you can see, we've applied this rule, and we have a warning that says, hey, this isn't used by any conduit in the network. So we have to apply this to a conduit. Alright, so let's go down here, and let's apply our QoS. It's going to be in basic settings. And right here in default set, QoS. Hit apply. Now it's set. We can go, and I'll show you our little warning is now gone. And I'll also show you where some of the defaults are. So you see the classes and rules. So here's some of your default rules that are already applied to the box itself, right? That we talked about earlier, and this is where you can find them and actually see them, and you can see the classes as well, right? Because those are the 10 through 16. Well, this was a basic overview of the QoS and setting up rules and what the options indicate. Thank you for your time.